today's topic is we basically decided we're going to hand this off to ProSoft because they have some new products that we think are beneficial to our market specifically. So I'm going to hand it off to Brandon and Eric.
Yeah, good afternoon, everybody. Appreciate your time. My name is Brandon Holashowski. I am the Regional Sales Manager for the South Central Region. So I'm located in Houston. Availability, all the time, and always here to help. So I'm going to hand it over to Eric Syme here.
I got one.
Oh, yeah, you do.
And my name is Eric Syme. I'm a Director of Program Management for ProSoft. And is it coming through okay? Audio? Okay. And so I'm based out of Denver. I handle most of our products that tie in with the oil and gas. And so what we were wanting to do is talk about some of our measurement, secure remote access solutions, and some data logging solutions, because we feel that they could be beneficial to some of your guys' applications. And so just a little bit about ProSoft. We're historically known kind of as the Modbus guys. We started working with Rockwell Automation 25 years ago, developing Modbus modules for PLC5s. Today, we still offer a lot of Modbus solutions, but we're focusing in on connecting different systems, some application specific. And that's what we'll really cover today is some of our IIoT solutions and our flow computing solution, which expands the use of Rockwell products for our customers. And so we have a full line of in-chassis solution, gateways, and then industrial wireless. We'll talk about one from each of those categories. In-chassis solution will be our flow computer, gateways will be our data logger, and then our industrial wireless will be our secure remote access solution. And so when we look at our strategic imperatives, we're really looking to focus in on some applications, get some growth through our emerging technologies, improve our customer experience, and then strengthen and expand our partnerships. And some of these key applications that are things from automated material handling with our wireless solutions, modernization, which Brandon will talk about real briefly at the end, where we help migrate and modernize PLC5 systems, SLC 500s, and then even systems from other vendors such as GE, Siemens, other vendors, and get those migrated over to Rockwell solutions. And then remote connectivity and integrated flow computing. So when we talk about remote connectivity, we've developed this ProSoft Connect, which for us, it's a cloud-based platform that gives you the ability to do things such as remote access and data monitoring. And then we've also expanded upon that for something that we just recently released, which is referred to as our persistent data network. And as this platform grows for us, data visualization is another thing that we're incorporating in there. But the first step for us was secure remote access. We wanted to simplify customers being able to connect to remote devices or machines that are not permanent and they may change locations, allow for the troubleshooting of these devices. Additionally, we've got a data logger, which I'll go into a little bit more later on, that allows you to very easily monitor data or log a bunch of data. And so this is not, if you think of a historian module and the uses of that, this is not necessarily a historian module. A historian's kind of a full-fledged data logging device, can be passed up into Pi. This is just something that allows OEMs, equipment builders, to be able to put a device that sits permanently on a skid or a machine and be able to log a bunch of information right there so that they can do troubleshooting, first fault detection, things that will help them in being able to provide better value to their customer without having to send a guy on site to sit next to a machine all the time. And then for persistent data network, as we launched our secure remote access, there quickly became a need to be able to quickly connect devices through a persistent data connection. So our secure remote access opens up a one-time tunnel, but you may have SCADA applications where you've got a device out in the field, or some of your customers may have acquired new assets. They don't necessarily have the infrastructure set up, communications back to their SCADA system. So this is really where we see one of the main benefits of this persistent data network. This allows somebody to, we had one customer with a water utility that was able to get connection for some new locations within 10 minutes. They're able to just go ahead and set up these cellular gateways, persistent data network, and within 10 minutes, they were receiving data between their assets. So when we talk about secure remote access in ProSoft Connect, some of the applications that we look at for this is well pads. You've got stuff scattered all over the place, and you may need to grab information from those devices. Food and bev, modernization, and of course, water, wastewater, and some broadcast type applications. And mining. The main thing that we talk about when you talk about secure remote access is just security. Everybody wants to know, is it secure? You can't go more than a couple of weeks without hearing about data breaches and security issues. It's happened to industrial control systems. So everybody really gets concerned about security. And so as we've developed this platform, we've worked closely with some IT professionals and found out what things are important to them and what needs to be in a secure remote access product. But then coming from more the automation side of things, we know what things are important to the automation engineers to be able to perform the functions that they're wanting to do. And so we've tried to incorporate this into a single platform with our ProSoft Connect. And so we've added features such as like vLotto, which is our virtual lockout tagout. That allows someone to basically, as we were talking with IT groups or plant managers, things like that, they wanted to be able to, if somebody's making a remote connection, they wanted to be able to authorize that connection. And so the vLotto system allows somebody to, it sends out a group email. Somebody has to go through and authorize that connection. If any one person comes through and says, no, I may have that plant or that machine, that tool down right now, that can automatically revoke that connection immediately. So it's a layer of security that it helps in these applications. It's an outbound connection only. So it's with the security, you can go ahead and limit it to an outbound connection so that you're not able to pass data, install new software, things like that could be used to maliciously affect a network. Two-factor authentication, something that we added in there to help increase the security. And we did something a little bit different. Some devices do two-factor authentication through SMS messaging. The recommendation through some of the IEC groups is that's not a very secure way to do it. And so we used a Google Authenticate application to do that. We used HTTPS web pages and 256 AES encryption. So and then we've done resilient testing or security testing with third-party agencies. And we actually have a remote access white paper that we've helped develop to lead customers, give them information that as they go down that path with secure authentication that they can present to their various groups. The two-factor authentication, like I said, is a token-based two-factor authentication where you basically have to log into a website with your password. It gives you a barcode that you can go ahead and scan the QR code, move it into Google Authenticator, and then that gives you your one-time connection code right there. So it's a lot more secure than a standard SMS-based two-factor authentication. And additionally, as we've developed this plan, we've developed there's a standard plan, which is basically a free service, and then there's what we refer to as power users plan, which provides even more functionality. And so on the Connect side, you can go ahead and connect multiple devices at the same time. Different people can connect to multiple devices at the same time. Now, one thing that I like about this is, especially for skid-based applications, there's no routing tables that you have to set up. If you've worked with other secure remote access devices in the past, you have to sometimes develop routing tables. And if you've got a skid that's got like a panel view, a PLC and a drive all on there, they're all Ethernet IP. You have to go through and change your IP addresses and your routing tables for port 44818. We actually use layer 2 network connections. So it's similar to the same type of connection as if you walked over to a switch that was sitting in that panel and you were able to connect to that. So you can go in RS links, you can do an RS who, it's going to show you your different tools. So for a Rockwell environment, that was one of the key things that as we worked with our development team, we wanted to make sure that we could utilize the same tools just like we were connected in a local switch, but just remotely. And so we do allow that. With our power user plan, you can have multiple people come in and connect at the same time through the same gateway. And so if you have one person that's doing some HMI screens, you have another person that's doing PLC code, they can both connect through the same remote access tunnel and perform the functions that they need to perform through that same secure remote access connection right there. And then vLotto is the dynamic authorization. And so, like I mentioned, it really provides some of the access that OT needs and some of the control that IT requires for these remote applications. And it allows authorized plant personnel to control when and how machines are accessed. And the authorized approvers are the ones that hold the key. Like I said, somebody can request access. Somebody has to approve it. If you've got multiple authorized users, any one person can revoke that access. So if a plant manager goes ahead and provides access, and then somebody else says, hey, we need to take that device down, they can immediately revoke that access for the amount of time needed. So the functionality for what we refer to as Easy Bridge is really that layer 2 connection. And so as I show here, you can have a PLC, a drive, an HMI panel, all on the same device, and you don't have to set up the routing tables. They can go ahead and have their own IP address set up, and you can still utilize all the same tools that you're utilizing as if you were connected physically to the switch. And really, you're just using this cloud-based technology to go ahead and perform the functions remotely that you would normally do right at the device. Yeah.
That feature, I think that's unique to you guys.
In remote access, yeah. Yeah. We've been doing remote access for a couple of years now, and that was one of the big caveats with remote access is especially if you had multiple devices, you had to go in, create routing tables, change the port numbers, do all that. And so that was one of my frustrations with it. Now it's so much easier to use. One of the key things also is we don't install third-party software on your laptop. So a lot of the services out there, they require third-party software to be installed. And with some of your larger organizations, getting approval for third-party software may take weeks. We use a native Windows VPN connection. And so it's basically already installed on every Windows-based PC out there. And so it allows users to get access to devices remotely much quicker than some of the other solutions out there. And it's one of, for us, this is one of the products that it definitely enhances the ability to perform a job. I actually, when I go out on site, I take one of these boxes usually with me every time. And that way, if I need help from one of my engineers in the field, I just put it in, have it set up, they connect to my box, and I can give them authorization. And then I was working on a well pad site in West Texas, and one of the guys, he believed what I was telling him because I sent him a trend log that showed the data, but he couldn't figure out how that happened. And so I gave him remote access. We were able to figure it out, and it worked out great. So even like within organizations, it's still good for being able to share information within organizations. Like I said, you can carry one out with you. You add somebody to your account, just say, hey, I'm going to give you access to this device. They click on a link, open up a tunnel, and next thing you know, it's like they're right out there on site with you. So it's great for sharing information and resources within organizations as well. So, but, and then, yeah, our power user plan, just there are different services or enhancements to the standard plan that allows for multiple users, additional data, more projects, and includes things like the two-factor authentication, the virtual lockout tagout, and then additional like data logging. And so as we started working with some of the IT organizations, they basically wanted to know when and who connected to each one of these devices out in the field. And so through different features that we've added, they can go ahead and do that. So. Yeah, I believe something like that. Yeah. The persistent data network, this is something that we just released. It really allows for some of a simple SCADA connection between devices. And so, so like I said, if you had a customer that acquired some new assets, they wanted to essentially get that information back into SCADA, but they have yet to install some of the infrastructure needed for that. They could utilize a persistent data network. And it really is, I mean, you have the hardware, you drag it into a project, and then these persistent data network connections allow devices to communicate back and forth with each other. And with a 99 point, I think our availability rate right now is 99.3% availability rate. And so, so you get a very reliable system that is easy to set up. And so for some applications that may be prohibitive for installing a tower and radio, since it's using a cellular connection, these persistent data network connections can be, it becomes cost effective because you don't have to install the infrastructure that goes with all that. And we offer those subscription-based services on a 1, 2, or 3 year basis, so that you're not having to worry about billing with the customer and coming back and monthly reoccurring stuff. So with the persistent data connections, you still get the ability to do some of the authorization access. you can do high-speed data logging. It's always on connection. So that allows you to tie that into your business systems, and then just really gives you again, a secure way to get information from multiple devices. Some of the main users that we see for this is water, wastewater, oil and gas applications where, like I said, you may have somebody that picked up new assets and they want to quickly bring this information into their SCADA. Industrial applications such as machine monitoring. And then one of the non-traditional applications that we have is like vendor managed inventory for like vending machines and things that sit out there where they want to have that persistent data connection to those devices. And so it's ideal for some floating installations where equipment may move from one site to another. And as far as like, if you look at a wireless network, you have to a lot of times do RF surveys, and you have towers and power that you have to have at certain locations. So this is utilizing a cellular connection. And so anywhere your site survey for something like that, so you take your cell phone out there and go, yeah, I've got 4 bars. And if you've got 4 bars on AT&T, you can, you would be able to utilize it, or 3 bars, 2 bars, you'd be able to utilize it for data connection. So that was about remote access. Any questions on that before I move on? Yeah.
So if you had the mod rock filled with the cell phone connected to it?
Yeah.
You put another one in wherever the SCADA server is, the cell connection?
Exactly. Yeah. So basically, you would have 2 units. You'd have a project, and so your project would go ahead and you'd define one that was on the SCADA server, and then one that was out on a LAC skid or a remote site. And once those are grouped together in the project, PDN network, they are automatically can start talking to one another. So.
Yeah, that's cool because you can leave it out on site, so you don't be there.
Yeah.
For a year because you want to work on the project, but you still want to support it.
Yeah.
You just install it, and whenever you're done, you're happy on your own, you can pull it out.
Exactly. Yeah, and that's so like with SCADA type application, as we released this, we first came out with remote access. That's what we focused in on first. And then we quickly had customers that were like, well, I don't want to log in every time and grant access and do all this. I just want it always on. And you could have done it with the old or with using like a static IP address. But as we've seen with some of these data breaches, I mean, I think the Target data breach was a prime example of that. They had a secure remote access solution with a static IP address that someone was able to tunnel through and gain remote access and acquire a bunch of data. And so, by having 2 different devices, they're really only talking to each other. It's on the SCADA side and on the other side, and it's an always-on connection. So it's a lot more secure than anything with static IP.
Have one sit next to you, plugged in while they're
Yeah.
out outside.
Yep, exactly. So it's similar to a wireless network, if you've got a wireless network, but it just is utilizing cell towers.
Are you guys gonna come up with like a remote one where like, where you can just carry one of these around? You hook up to it and you can hit all your sites, that way you're still secure.
Like,
Because you're saying like, yeah, theoretically, it's more secure to have 2 of those, right? One's
Yeah.
in your office, right? One on site.
Yeah.
But what if you're not in your office? You're at home.
Oh, okay. Yeah, you would have to have the hardware with
Right.
you. So yeah, that's yeah.
That's what you're saying.
Yep.
So, we've seen a lot of this on remote tanks. Good for your officials where they're not having out.
Yeah, because I just seen where I can remote out to West Texas, but I gotta like the Citrix, I got to remote into a server, and then from that server, I got to remote into
Yeah.
another server. That's how they would keep
Yeah.
it secure.
Yeah, and by the time you actually make that connection, something happens
But
and
the
you
only
got to
way
go
do
through
that
it.
is you have to be the IT admin for a corporation.
Yeah. Yeah, and so that's where we've tried to incorporate some of those IT level authorizations, but still for the application side, make it easy on the application side. Yeah, yeah. But no, it's actually been a good product line for us. We not only have the cellular one, but we also have a wired version as well. So if you've got a customer that's in a plant, they've got internet access through the plant, they can go ahead and hook one of those up, and it provides the same functionality just over a wired network connection.
You can set up a VLAN just for that.
Exactly. Yep. Yeah, and then the nice part, because it doesn't install any third-party software, it uses the native Windows VPN connection. You don't have to worry about updating software. You don't have to worry about potential security issues with that. So
What if you're in a plant that's got multiples of these, and you plug your laptop into the same VLAN? Are you able to, and if you have an internet connection, are you able to go up to the ProSoft connection to those devices?
Yeah.
In the plant?
yeah, so as long as you've got like an internet connection, it's just basically it's a VPN tunnel.
Yeah, 'cause I know
And-
sometimes the plants, they don't want you hooking up to their network.
Yeah.
But, like, I mean, I was out in the Eagle Ford, and they're like, I showed up on site to commission the PLC, and they're like, oh yeah, you can't do anything because you can't plug it into the
Yeah,
network.
yeah, yeah. Yeah, everybody gets concerned about and yep. But no, it provides a lot of flexibility in your application. I mean, for me, the best part about it is like I take one with me, and if I need help from somebody smarter than I am, I can just, hey, here, I'm sending you access, and exactly, yep. All right. Well, that was it on secure remote access. So let's roll into measurement requirements with oil and gas. So really, I think there's some questions that came through real quick.
Does it work only on cell network?
So we do have a LAN version. So it's a wired Ethernet version. Wi-Fi, we do not have one that has Wi-Fi capability built into it. Yeah, but it could be connected to, if you had a hotspot, that hotspot connection, as long as you basically have internet access, you can go ahead and connect through the cloud security for the remote access. So I think that answered the question. All right. So when looking at measure flow computer applications, so flow computers are used out in oil and gas for measurement applications, and so a lot of times what we were seeing installed in the field was something very similar to this type of an architecture, where you had a control logics PLC, controller compact logics. You had standalone flow computers that were doing the measurement of oil and gas. And all of that information was required to be tied up to control or to SCADA system. And so the amount of equipment that was on the well pad site was increasing. In some applications, and some of this occurred during like the 2014 time when people were trying to kind of right size the applications, they would go ahead and remove some of the PLC, and because measurement became one of the critical, it was very much so the critical thing that needed to be performed on a well pad site. So they would go ahead and give up some of the automation system and just go ahead and install flow computers, do some level of control with the flow computers, and give up the PAC that was doing that was actually helping do the automation on the site. So really, when we looked at some of there's traditional flow computers from vendors such as Emerson, ABB Total Flow, SCADA Pack. And so we saw everything from applications that had standalone or control logics installed on site with standalone flow computers to applications where just the flow computers were doing the measurement and also doing control. But the I/O counts are extremely limited on some of these pieces of hardware. And so as the well pad sites were increasing, we saw more and more equipment being required of these standalone flow computers on site. And that increased the amount of hardware, software, and licensing that needed to be done there. So what we've developed is an in-chassis flow computer. And so this is a coprocessor module that sits directly in the control or compact logics rack and allows those measurement-related functions to be done within a Rockwell PLC. So control or compact logics. This allows customers to really take advantage of things such as distributed I/O. So Rockwell architecture natively supports distributed I/O. So you can place I/O blocks such as point I/O out at the wellhead, out at the separators, at the tank batteries themselves. And it helps reduce cabling. You're not having to home run all that wiring back to the control system. And it gives a very flexible architecture that as the well pad grows, and additional I/O is needed, they can drop in an additional I/O panel with distributed I/O there. But when you talk about measurement related requirements, there's some very specific functions that are required, and that's why you're not able to necessarily do that directly in a Rockwell PLC. And so when we talk about measurement, it's there's things that the API requires, things such as archiving a minimum of 35 days worth of history, both hourly and daily history. They need to have a audit trail. So if any parameter gets changed, that can change the measurement. So if somebody comes out and changes like an orifice plate or changes a meter factor or a K factor, you have to have an event log that basically keeps track of who made that change, what time it was changed, and what they changed it from to. So if they change from a 5-inch orifice plate to a 6 1/4-inch orifice plate, that has to be part of an audit trail. When we talk about an interface to SCADA, with measurement type applications, it's not just factory talk view. A lot of times it's SCADA systems such as Signet or AutoSol or different measurement related systems. And so you had to have an interface to SCADA, and traditionally that's done through like a Modbus or an Enron Modbus connection. And then you had to have all these measurement compliance standards. And so the API goes ahead and publishes all these standards for correcting measured oil and gas to reference conditions. And it's everything from like AGA 3, 7, 8. And then they also publish standards for API 21.1 and 21.2. And those are the requirements for history. So these are all very specific functions that from a measurement perspective they have to be met for custody, transfer, or allocation-based measurement. And you can't just do those within the PLC. So that's where the coprocessor module came in play. So some of the applications that we've done with this module over the years, things like LAC skids, gas plants, pipeline monitoring, and the multi-well pad. It's a great solution for Rockwell PLCs and the ProSoft module to be able to solve these measurement applications. Things like a LAC skid, an L24 or L27 is a really good LAC controller because it's got high-speed counter, built-in analog input. And then if you can combine that with a measurement coprocessor, it gives you a cost-effective solution for a LAC skid that's all built on a Rockwell-based architecture. So this is kind of a sample of something for a LAC skid where you can use the L24, L27. You can use anything from gateways or Modbus communications to things like a Coriolis meter that's on that skid. A lot of the Coriolis meters are also starting to build in Ethernet IP. So you can bring that information directly into the controller. And so you're bringing things like your pulse count or pulse frequency directly into the controller, as well as density. And then you pass that information over the backplane to the coprocessor module, and it sits there and does the API calculations and then passes that result back to the PLC. So instead of having two different controllers or a controller and a measurement solution on a skid, and then having to network the data back and forth between the two, it's all in the one platform, so it allows you to get all the information that you need. There's additionally no licensing fees for liquid or gas applications. When we looked at some of the other competitive flow computers, they will a lot of times offer gas, and then you have to pay an additional licensing fee for a liquid. And if you're replacing, say for instance, a device goes down at 2 o'clock in the morning, you have to transfer license from one device to another or get a license fee to be able to do liquid measurement runs. That was something that we really, as we worked with customers, we wanted to eliminate those licensing fees right there. So we had a particular customer that actually used this on a LAC skid, and they were able to go ahead and incorporate the compact logic system. They were able to go ahead and put in a measurement coprocessor module there. And they actually also utilized the ICX35 product, the cellular gateway that I talked about earlier, so that they could actually go ahead and grab the measurement data from the system and remotely, and they didn't have to dispatch people on site to gather that information, as well as be able to perform all the measurement and control in one platform there.
Question is, EFAC now have software support for scheduled auto generation?
Yeah, so we do have a CFX generation. We've added in support to our CFX, our scheduler, or our scheduler software that allows it to be scheduled through a Windows scheduler task manager. And so we added some support for that, so it can run and generate those CFX files on a scheduled basis utilizing a Windows scheduler right now. So with this particular, with Pelican, they were able to combine their measurement and automation solution into one platform. And they were able to go ahead and, like I said, utilize ProSoft Connect to do uploading of historical data as well as troubleshooting applications remotely. So they were able to utilize both of those. Another key application that we see for this is the multi-well pad sites. And so as these sites have grown larger and larger over the years, we're seeing customers that are building sites now for 6 and 12 well pads on a regular basis. And so the amount of IO, the tank batteries that are out there, the separators, all of that is increasing on each one of these sites. But most of these sites have grid or generator power. And so power requirements on previously standalone flow computers were great because they were low power units or RTU based. But with grid or generator power at these sites, you don't necessarily have to worry about power consumption. And a lot of times they have control houses and then high bandwidth data communications to these sites. So, so with the amount of automation on those sites, what we're seeing is a lot of installations where you're using one or multiple standalone flow computers to do the measurement. And then you were doing a lot of times they're using like a Rockwell, either controller, Compact Logix, PLC to do the automation on those sites. And then sometimes you're using gateways or RTUs to basically network back and forth between the two devices. And so as we're doing the commissioning and setup of these sites, it just increased the overall automation or the amount of time that it took to actually commission and set up these sites, as well as you had multiple devices passing data over through a wireless network back to a SCADA host. And so it increased your load on your communication network. So with the in-chassis flow computer, we're able to combine that into a single architecture. And it's an architecture that it can be expanded upon as the needs on the well pad site increase. So one of our customers that we worked with on this, ARC Resources, they were basically they had assets up in Western Canada, and they wanted to really focus on creating value for their application. And so their current flow computer couldn't scale to what their larger well pad sites needed. And they actually had some issues where they could potentially freeze. And so they really wanted something that was not only scalable, could reduce cost, and was a platform that they could move forward with. And so they had been using the Rockwell PLCs and another flow computer solution. And so we went ahead and presented them with the idea of how they could go ahead and streamline that. And so what they were able to do was their old system was limited to 5 wells on a system. And because of the coprocessor module that sits in the Rockwell chassis, they were able to expand that to up to 32. They were also able to completely eliminate a second control panel that housed their standalone flow computer, because now their flow computer was just sitting in an additional slot in the same Control Logix rack that they already had out on site doing all their automation. And they're able to pull in some existing Compact Logix IO, and they were able to reduce their total programming. So really, when we look at some of the cost savings, we had a particular customer with a 12-well pad application that said that they could reduce costs just $50,000 in hardware costs alone. When you factor in the additional licensing, spare part reduction, and then as well as engineering and time, the savings were even greater. But being built on a scalable platform, it allows customers to go ahead and utilize like Compact Logix L24 and 27. Like I said, those are great small LAC controllers because they've got built-in high-speed counters, analog signals. You add measurement as one of the functions that they can support, and it can control and produce the measurement records for a LAC system. But as somebody's needs grow on the well pad site, they can go ahead and migrate up to L30, L33, L36, and eventually on to Control Logix and L7 or L8 processors if they want. And so the fact that everything's built in Studio 5000, A lot of the code that is developed on smaller systems can be migrated over into larger systems. So as the needs of their well pad site, as they go from 6 to 12 to 18 or 24 wells, they can actually reuse some of that code. They can use add-on instructions that they've built and developed and migrate that into larger and larger platforms. And additionally, they can take advantage of the distributed I/O that's natively supported within the Rockwell architecture. So you can put your I/O directly near the separators, the tank batteries. If you've got systems or areas that are spread out geographically, you could even utilize wireless communication to I/O. That's something that it helps reduce the overall wiring that's being done on site and gives a lot more flexibility to the customer and what they're able to support. And then since the Rockwell hardware architecture supports anything from HART to Modbus, Fieldbus, Profibus, they can also pick whatever instrumentation they want, and they're not tied in with a particular vendor's instrumentation because the Rockwell architecture supports almost all of the main networks that your multivariable transmitters and your Coriolis meters, your pressure and temperature meters out in the field are utilizing to get that information back to a flow computer. So one of our customers, actually, this is his line, cost-effective, industry-shifting, scalable marriage between between automation and measurement. It allows someone to utilize a coprocessor as their needs increase. So when I talked about ARC resources, they first started off with a single ControlLogix module. And then as they went from a 6 to a 12 well pad, they needed a second module. And so they were able to add an additional module, and they didn't have to add an additional flow computer on that site. And so they were able to take advantage of this, utilize all that code. And then so one other thing, as we've worked with customers though, measurement has some particular functions that they require. They need to be able to calibrate transmitters. They need to be able to enter orifice plate changes. They need to be able to enter new meter factors as they prove Coriolis meters. We've created an EAFC manager software, which is standalone Windows-based configuration software that allows measurement teams to still be able to perform some of those functions that they need to make sure that their measurement is accurate and complies to the API standards. And so that EAFC manager allows them to do that without requiring a license of Studio 5000. So as we've talked about the API requirements, we've got two different platforms, Control and Compact Logix. And then our ControlLogix allows for up to 16 measurement runs. And those can be any combination of gas or liquid measurement runs. So certain other devices out there have a limitation of you can do 6 gas and 6 liquid, or 12 gas total, but you can only do 6 liquid. This can do all 16 liquids, all 16 gas. It's up to the user to select that. And there's no licensing fees for any of the meter runs. So basically, you're purchasing a coprocessor module. It's a hardware-based solution that ties into the Rockwell architecture, and it allows you to perform your measurement functions. There's no licensing that you have to get through transferring license keys or anything like that over. When we talk about archiving, that's kind of one of the main things for standalone flow computers. They have to have not only a secure archive trail, but they have to be able to archive at least 35 days of hourly records. And so we're able to support up to 60 days or 1,440 hourly records. And that information is all stored in non-volatile memory directly in the module itself. So say take for instance the LAC skid. If that LAC skid's placed on a location and site, You power that thing off and you move that skid to another location. And a month later or 2 months later, you power that system back up. The memory is actually maintained in the ProSoft AFC module through non-volatile RAM, and is stored in that module directly so that you don't lose any of that measurement related data. The Windows-based software, like I mentioned, measurement divisions, they have to be able to do certain functions related to measurement. And they don't necessarily want a Windows or a Studio 5000 license. And a lot of times your measurement and your automation groups are still separate groups. And so the automation guys don't necessarily want the measurement guys going into PLC and making changes. So this software allows measurement groups to go ahead and make whatever changes they need to make for gas analysis, orifice plate, be able to enter meter factors, basically set up and configure the measurement related functions independent of the Studio 5000. So it kind of, like I said, it's a coprocessor that sits in the rack that performs measurement related functions. And then on the export functions, or actually you also have the ability to do transmitter verification and calibration. So within a lot of measurement related organizations, they go out monthly or quarterly and they calibrate multivariable transmitters. This software will allow them to do the transmitter verification and calibration of those devices through the EAFC manager. And then if they need to, they can also export the data into FlowCal CFX files. And so that was as we started working with customers, the tie-in to SCADA was critical, but also the ability to dispatch somebody on site. If you lost a SCADA connection, they needed to be able to pull that measurement data out of a flow computer. That was also critical as well. So we created a utility that does that. On the SCADA side, I mentioned Modbus TCP/IP is a lot of the flow computers are utilizing Modbus TCP/IP, and so we were able to add support for Enron Modbus, which is basically a file transfer for historical data that a lot of flow computers use. And that allows us to tie in with systems such as Signet and AutoSol to pull that measurement data. And a lot of times those systems will pull that measurement data. They'll utilize those systems to look for any abnormalities in the measurement related data, make corrections if something like a transmitter failed during that time. So they're able to get all that historical data and still perform whatever functions they need from a measurement perspective for that. So really when we look at the top 5 reasons that for an in-chassis flow computer, the main one, license-free. That's something that as transferring licenses over to a flow computer has been a frustration for some of our customers on existing products. So we got a license-free model. Being able to utilize a modern PAC architecture, it just allows users to take advantage of everything that add-on instructions, being able to have code libraries that they can move from one platform to the next, engineer it once, and then just reuse it as their needs grow. Also being able to combine that with a coprocessor that if you need additional metering, what we've seen with some of our customers is they're now, previously they were limited on their system, they were only measuring oil and gas. Now that they can just add an additional module on there, they can now measure oil, gas, water, and get that same API compliant information for water measurement that they weren't able to do before because it would require additional hardware. Now it just requires an additional card in the chassis. The AFC Manager software being a tool for measurement groups is a free configuration software. the ability to use distributed I/O and place your I/O out near your separators, near your tank batteries, near your wellhead, provides a lot of flexibility in the architecture, can decrease the amount of wiring, decrease your commissioning time, and allow things to get these sites started up quicker. And it's one of the few times that you can actually say that in some of these applications, a Rockwell solution is actually a cost-effective or cheaper solution than what they're doing right now. So they're getting all of the benefits of the Rockwell architecture, and it's now a cheaper solution than some of the ways that they were doing it in the past. So, and increases a lot of flexibility there. So,
What's the price on the card?
so for ControlLogix, price is right around $3,500 for 16 meter runs, and then CompactLogix is $2,000 for 12 meter runs. So
Is there a limitation on the versioning for the Studio 5000 RC?
anything above 16 or above. So we create the add-on instructions in version 16, and then that, and so it's easy to go forward on the versions. It's not very easy to go backwards. So we create them in 16 was the first version that supported add-on instructions. So.
So in order to use this module, you still have to bring your flow through a pulse input somewhere on the PLC?
Not necessarily through pulse input. Pulse input is definitely one of the options. I have a customer that was actually off their Coriolis meter. They were bringing the pulse frequency and density through a Modbus interface. And then this was coming off of a separator. So then they had a separate pressure and temperature transmitter off of the vessel on the separator. And so they were able to, they actually brought that in via HART. So they were getting Modbus for density and pulse frequency.
Like serial data basically.
That's correct, yeah. And then so, I mean, really it can be analog, it can be high-speed counter, it can be Modbus, HART.
So when you go link all that stuff through your backplane, you just set it all up in that configurator or whatever?
Yeah, well, actually, that would be through the add-on instructions. So we basically, in the add-on instruction, you would have a liquid measurement run for something like that. And then there's a tag in there for density, pressure, temperature, frequency, and water cut if you're using a water cut percentage. And then you can either alias or you've got your signals coming in via HART or via Modbus or a controller tag or through an analog signal or a high-speed counter. And then you just go ahead and tie that to what the measurement
So all that
run.
data then gets transferred to
Yeah.
ProSoft module.
Yep. So basically the data lands first into Logix, and then Logix goes ahead and through the add-on instruction pushes that information to the coprocessor. Coprocessor runs the API calculations and then goes ahead and passes the results back to the processor.
Yeah, so have you guys seen any issue where like you'll have like all the flow data coming in from the field and then you bring it into the PLC and then you have like another check meter right next to it. And then you have 2 meters that are in this one coprocessor. Because I've experienced this where like I wasn't reading the flow data fast enough for Modbus.
Yeah.
So I had one meter that's saying you're doing 100 ppm, the other meter is saying like 110.
Yeah.
But then I sped it up and it was like 100 and 101.
Yeah. Yeah.
So how do you guarantee that, you know, when you take a pressure, temperature, and a pulse snapshot, that they're all within, you know, I guess, milliseconds of each other?
Yeah, so we have what's referred to as a sample rate alarm within the flow computer, where we look at the process inputs and how quickly those are changing. And then we will go ahead and we still perform calculations, but if you hit on a sample rate alarm, it'll go ahead and flag an alarm in there. And then the other thing is, I mean, we try to as we work with customers, we try and work on helping design a network that, so like on a heart signal, you don't necessarily have to worry about that. Analog signals or high-speed counters, you don't have to worry about that. The RPI time, so the API spec is 1 second. The RPI time max that you can set in a Logix processor is 750. So you know you're going to get data fast enough off of that. When you start talking about Modbus, that's where you can go ahead and get beyond the specification, and that's kind of why we put that sample rate alarm in there. But then a lot of times when we're doing designs on certain systems, we'll go ahead and you can get 6 devices on a Modbus channel and go ahead and still get data updates within 1 second. A lot of times I like to be conservative and put no more than 4 devices on a Modbus channel, and then we'll set the Modbus response timeout to 250 milliseconds. And what that does is that ensures that as long as the device, or even if all three of the 4 devices did not communicate within that 250 millisecond, you're still going to get that 4th one within the 1 second time frame.
Yeah, because I noticed that the flow co-processors got RS-485 ports on it.
Yeah.
And did you guys put those there so you can integrate the Coriolis into those ports?
Eventually, yes. That is actually one of the roadmap items that we're working on right now, is direct polling to MVTs and Coriolis. But
so, and then also the flow computer will do density calculations based on your temperature and pressure.
yes.
And you can set whatever lookup tables you want in the flow computer.
So it uses the density calculation off of, there's different tables based on the product grouping for the density calculations that are published by API. And so there's under liquid, you've got a couple different fluid types that you can select. And then it pulls in different tables based off of that.
Yeah, so you could have like temperature and pressure of ethylene and look up the specific gravity of it.
Yes, yeah, and so there's actually a setting in there for specific gravity as well, or specific gravity or relative density, and so you can go ahead and assign that as a default value, and there's different tables that are pulled in. There is so actually density is one of the process inputs on liquid measurement.
Okay.
So you would
So we'd have to measure.
you would go ahead and you could enter that through. So like on I just remember on our water measurement, we basically in the PLC, they weren't pulling that value from any instrumentation. They used a hard-coded value. It was like, I think 737 or something. And so we just put that into the PLC and then it used it that way. So like for something like you mentioned with like ethylene, you would look, you would just look up what the value is for that. If you didn't have a live density as a process input. If you did have a live density off of like a Coriolis, then that becomes a process input value. Yep.
So today, if you were to install one of these, you'd have to make sure you have some way of counting the pulses, and then or integrating it over Modbus, the Coriolis, and then having temperature.
That's correct. Yeah. Yeah, that's where we've seen, I mean, it really all depends on, I mean, I've got certain customers that do not like to use pulse input. They run into grounding issues in the field that can give them false pulse counts. So they will bring that information via Modbus, and then they'll basically bring in the pulse frequency because they have better luck there. Other customers, they always require a pulse input signal. And so, yeah, we've been able to support applications with and without high-speed counters through Modbus. We've done applications where you're talking to multivariable transmitters over Modbus.
Is it better to have the Modbus module in the chassis, or because I know you can get the PLX31?
Yeah.
It's really nice because you can combine all the tags outside the processor and just write the tags in the PLC.
Yeah, So for me, it actually really depends on how many devices.
Yeah.
The PLX31, on a couple of the architectures we've designed, PLX31 works better because you've got 4 independent serial ports on there.
Right.
And so if you're only putting 4 devices per port, you can now get 24 devices on one module. If you've got a smaller architecture, sometimes putting the module in the chassis with only 2 serial ports is beneficial. And then we've also even done some stuff where customers are using the point.io module, Modbus module. And for them, it's beneficial because they've already got a point.io out there out near a separator panel or out near a tank battery. And so they can go ahead and just use that and not having.
Have a high-speed power?
Yes.
Oh,
Yep. Yeah. I think it's I believe it's 2-channel, the high-speed counter. Yeah, it's 2-channel card. But yeah, you can build those point.io racks out to 64 slices. So you can. Okay, they say you can. So you would have to use a lot of EP24s. Yeah. But yeah, we. Listen to this guy. Yeah. I go based off the rock.
Where I've just heard the complaints when you take device net to its limit. That really is what's on the backplane. So
Yeah.
You're really not gaining. You really look at it, the numbers.
if you're using point.io and have 40 slots of point.io, you should have used another IO platform. That generally means you're better off using increments of 8 and 16. So
Yeah.
yeah.
One of the things, I like actually using the gateways or the in-chassis modules because especially when you start talking with measurement, through point.io, they have to get back into the processor to get some of the diagnostic data, or that has to be brought out to an HMI. But through either a gateway or one of our in-chassis Modbus modules, they can actually connect directly to that module and start troubleshooting the Modbus network. So that's another benefit of using the gateways.
You can always stick those PLX31 modules in the same place.
Yeah.
But you have like your temperature and pressure.
Mhm.
And all of it.
Yeah, and as 4 ports of those are a PLX31 with 4 Modbus ports on there is going to take up a lot less room in the on a DIN rail than 4 Modbus slices out in the rack. So, yep. And really, it comes down to some customers having an aversion to that's a single point of failure, and so they'll want to break up the networks into smaller.
And on measurement, people might feel more comfortable with the actual Modbus part than the chassis.
Yeah. Yep.
Set the numbers in for-
Yeah. So yeah, it's really based on, the flexibility in the Rockwell system with gateways and Modbus modules, Heart, Profibus, the flexibility is there. It's really what the customer's comfortable with, what functions they want to be able to perform, and how they're going to access the data.
So you said there was like 1,440 hours of data measurement. Is that basically the accumulator, the previous day value, the day value, or is it just?
That's per hour. So every hour the module automatically cuts an archive record, which is going to consist of everything from the flow weighted average of the process inputs to things like temperature and pressure correction factors to all your measurement data. So by default, we set up our archive structure for that API 21.1 or 21.2 compliance. So because they call out in their specification, they call out to be compliant with API measurement, you should record these, and I think it's like 36 values for the measurement. And then we also allow users to record additional data on top of that. So if like one user I have is actually recording drive gain off a Coriolis meter, and they want that as part of their archive data. And so they're basically drive gains not used in any of the calculations, but they're passing that over to the module. It becomes part of the archive structure so that they can look at it on a SCADA side or through FlowCal or different databases. Oh yeah, yeah, that's actually on the Compact Logics module. The memory card's actually not used right now. So it's non-volatile RAM that we used on that, but we put a memory slot on there for potentially future storage. Yeah, yeah, we thought about there. Yep, yeah, the connector was cheap to put on there for now. So, yep. All right. Any other questions on that? All right. And lastly, data logging. So as customers you hear a lot of stuff about IIoT, and really the key thing is people want more data. They want more access to the data and make better, more intelligent decisions. And so what we've designed was a small data logger module. And really what this allows someone to do is kind of similar to remote access, gives you connection to data from different equipment. But it allows you to automatically log the data on a continuous basis. And so in some applications, you can do that on an HMI panel. You may be able to do trend logs through a PLC if you're troubleshooting. But if you don't necessarily have a connection to that device, this allows you a way to basically install essentially an appliance that sits right next to the device, grabs a bunch of information, stores it in a log. And so one customer that we worked with on this, they had on some of their pump jacks, they just wanted to record a bunch of data that they could view in case of an alarm. I had another customer that as they put a new well on site and it's a free flowing well, they wanted to log tubing and casing pressure off of this well, 1 second data for the first 30 days. Once they were done with that, they'd pull the device, they'd take it in, give it to their measurement guys, their reservoir engineers, and then they go ahead and take that device and install it to the next site. So it's just the ability to access that data. I mean, passing 1 second data for 30 days over a SCADA network connection might be prohibitive to some of the remote communication. So being able to install an appliance that sits right there gives them the ability to add that data over there. And then you also have some instances where your network connection may be intermittent, but it's still critical to be able to understand that data. And the platform for the data logger is actually this, I should have taken these out, but it's this little slice module right here over on the far side right there. It allows users a very easy way to go ahead and monitor some equipment. For our OEMs, they may want to, we had a couple of OEMs that they sent equipment all over the world. And in case something happened, they wanted to have, be able to go back and look at the data. So if something broke on the machine, they'd want to go back, look at the information, and go ahead and try and figure out what was the root cause of that so that they could help build their machine better or avoid this problem in future applications. So being able to just install an appliance on a machine helps with things like your troubleshooting. So if you're troubleshooting some type of an intermittent connection or something that randomly occurs at 2 o'clock in the morning on a Thursday, this is something that you can go ahead and install right there. It logs a bunch of information and then puts it into a format that it can be pulled out directly from the unit itself in just a CSV format. So when I said earlier that it's not, Rockwell has a solution for a historian module that ties into Pi. That's a very, very powerful solution for customers that are using that entire architecture. This is really something for your troubleshooting, your maintenance guys. This is for people that, I mean, when I was doing troubleshooting, I would be setting up trend logs in a Rockwell PLC so I can grab all this information when I'm on site. But if I'm not on site, then how do I do that same thing? I've actually, one time I sent a computer out to a customer and asked him to just set that computer there so it could log data for me. This would have been the appliance I could send out to the customer, say, hey, put this on this machine or on this tool, log that information, send me the CSV file, and we'll figure out what's going on with it. So it's got a lot of, it's got some different logging modes where you can go ahead and store the memory until it's full, or you can go ahead and use it on a FIFO buffer where it basically kicks out the oldest records as soon as it fills up. And the data logging can be triggered through anything from a time-based change to a heartbeat to a tag trigger. So you can go ahead and set it up to, if this occurs, go ahead and log data. So you've got some different trigger options in there. The module itself supports Ethernet IP, Modbus RTU, Modbus TCP/IP, or DF1. So it can be used with equipment, our Rockwell PLCs. It can be used with Modbus TCP/IP or Modbus devices, and then can also be used with DF1 if you had a SLIC processor out there that you wanted to log data from. It does support up to 3 devices. So if you had an Ethernet IP processor out there, you had a drive via Modbus, and some other devices, you can connect up to 3 devices, and then a total of 200 tags can be set up. And it can read and store up to 16 million time-stamped records. And that's all, how long that consists of depends on your logging frequency and how you set it up. I mean, if you were doing something relatively slow, this could log information for years. If you're logging information very quickly, then it could log information for days or months. So, yes.
You log certain data at different rates.
Yes.
You want a heartbeat, like as many as you can, or do you have a limitation?
That's a good question. Yeah. Yeah, I don't have my VM.
From my personal experience, it took about, we set up about 10 minutes. And I had a use case about a year ago where I was working for a company, and your brother was involved in it, where we were trying, a company that makes aircraft hardware for the aerospace industry. They had to record temperatures. Their machines or heaters they had that were doing it, they just haven't had a micrologics controller. I don't know who the OEM was. We set it up through the controller.
Mainly, yeah.
Some of the two heaters had reports on it, so we had to put micrologics into it. This would have been a perfect solution because
Oh, yeah.
Just change it however you want, right? Because I can change
and the
each
tag
one.
Yeah.
routing is so
Okay.
easy across the dash.
Yeah.
On the tags. But it's also a $600 module too. It's cheap.
Yeah.
So,
It's
something I wish I had this product a long time ago. Yeah.
Yeah, it looks like you can set up each of the 200 tags at different intervals if you want. I'll confirm that, but it just, in looking at the software right now, it looks like you can set each one up differently. So, yeah. Yeah, it's, and then the different data types it supports is kind of the native, Boolean, cent, int, dent, and real data types on the Rockwell architecture. And that was about it.
Is there a cap on the file size for the card, storage card?
So it's actually stored locally on the unit. In memory on that, there's not a SD card or anything external to it. So to grab the information from it, you would connect to the IP address of the module and then upload the CSV off of it. So
What size is that?
it's 16 million records. Yeah. And yeah, 16 million time-stamped records. Each one of them has an individual timestamp. So I think I'm not sure how much data that equates to, but yeah, it's based off record size. And then once it gets full, like I said, you can either set it up and get rid of the oldest data or stop logging. So, yep. Yeah.
Is it going to support the new date types coming in version 32?
That is a good question. I just, as I was looking at that, I was just thinking that so we need to add a couple more data types. So yeah, the version 32 finally came out with unsigned data types. So unsigned int, unsigned dent, and then double real, right? Yeah, 64-bit real. And so, so yeah, we released this about 6 months ago, and before 32 came out. And then as I've been working with Rockwell on another thing, I haven't upgraded to 32 yet, so I didn't know that existed. And I got really excited because I've had to do 64-bit math calculation in the processor without being able to use a compute statement on it, and that was not fun. So I gave up after about 8 hours of working on it, and I asked one of our developers how he would do it. And he finally told me, well, you got to do this and this, and then carry this number and do this and put it. I'm like, okay, got it. So yeah, we'll I'll need to work on getting those data types added in there. I don't think that should be an issue. It's just a matter of getting them added into the GUI and support added for that. Yep. So that was all I had.
Yeah, I just
Brandon?
know that everybody who's on WebEx can't see this, but kind of wanted to touch on our.
They can't hear you either. No,
I talk kind of loud, so.
not on WebEx.
Okay, well,
It's not that loud.
not loud enough. All right. So for modernization and migration, we have a product. It's the ANX2AB. It's an Ethernet module. And so as technology is advancing and a lot of customers are kind of, wanting to rip and replace, they're upgrading their PLCs and making changes. They want to do it all at once, but they may not have, the budget CapEx to do so. So what this module allows to do, and it's been very successful, is to allow customers for their plants to do this in phases. And it's a simple plug and play to where, you kind of hook it up and it has the code in it to where you can basically make the change from, and the upgrades from one PLC to another. And it's very simple and easy to use. We've had, like I said, really good success with it. We're working with a few customers right now, food and beverage. But it works, all, if you're talking oil and gas or all verticals, right? So I know that we spent a lot of time on really what we wanted to hit on was the, Flow Computer and ProSoft Connect, but I kind of just wanted to, brush up on this. It's something to think about. You can do things in phases rather than having to, shut down the plant or the operation all at once. That really helps customers out. And they see the value of that. So again, that's just something that I wanted to brush up on or kind of touch on. And then lastly, I kind of wanted to, like Eric said, we're kind of known as the Modbus guys, but we've really expanded our portfolio. And so we have our wireless radios, which I'm sure you guys are aware of. So, the 900 megahertz, 2.4, 5, and, the frequency hopping. So, we use these, oil and gas, again, several verticals, right? Um, and they're really sturdy. We've had lots of success with them as far as distances are concerned. We go far distance, we can travel far distances, and they are. What's the furthest? I want to say it's
10 miles.
You're going the theoretical route, and you don't ever want to do that.
yeah. So theoretically, I think it's further than 10 miles, but there's ways around that to even go further. So yes, and now it is line of sight.
You're like, yeah, I got flow rates and so I'm decided to put a rig. So the next thing,
Correct.
And always have line of sight,
Correct.
and you guys will never have line of sight when you follow me on it.
With wireless, we offer services.
Yes.
For site surveys and path studies, where we'll actually.
We go out and do the survey, and we have the Google Maps and all that, and to ensure that it's going to be successful.
ProSoft has a very good, a pretty good, you change the online configuration for wireless where you can set your points and distances. And it will actually tell you whether you have a working signal, but it'll also help you with your antenna selection. So a lot of times that Yagi or Yagi direction.
Mm-hmm.
So it's really good, especially if you're trying to put together oil materials, and it does the little things like make sure if the antenna is going to put a curve, you should have a line on that in the equation too. So it can give you at the very least help you on your because every part of the components you'll need. So it is a free download off the
Yes.
website.
Correct. And we also have several YouTube videos off of our website that are actually really good. You can learn a lot off of. I know I have. So please take a look at those, and I have my business cards here. And with any questions, you can always get a hold of me. Like I said, I am here locally in Houston, and make sure that you're taken care of for your customers. So with that, thank you guys for attending. We really appreciate it, and look forward to working with you.
Thanks a lot.